Hello everyone, in this video we will be solving problem 2943, maximize area of square hole in grid. The problem statement is, we are given an m by n grid with h bars and v bars as removable bars in it. The aim is to calculate the maximum square hole in the grid that we can make by removing the bars in it. In example number 1, the values of n and m are 2 and 1 respectively, so the corresponding grid will be add 2 to each of them. That gives us the grid of size 4 and 3. We have two bars which can be removed horizontally at position 2 and 3, which I have highlighted in red arrows, and one vertical bar at position 2. One possible combination is to remove the horizontal bar at position 2 and vertical bar at position 2. That gives us a square of side 2, giving us the area of 4. There is one more possibility where we can remove the horizontal bar at position 3 and the vertical bar at position 2, which will give us a slightly different variation of a square, but the total is still the same. I hope this example was helpful. Let's switch to whiteboard and discuss possible solutions. Let's use this example where m and n are 3 and 5, and the first vertical row highlighted in red is removable. I'll extend the example to also say that the horizontal bar at position 6 is removable, and so is the horizontal bar at position 2. As you can make out, after removing those columns and rows, we have two square holes of size 2 each. If we assume that one more column at position 3 is removable, after removing that bar, you can see we can build a bigger rectangle but not a square. And this change is impactful to both the squares that we have built earlier, the first one at the top and the other one at the bottom. Now if we had one more horizontal row at position 3 that is removable, we could have built a bigger square of size 3 at the top. As the area of the square is going to be 9, which is side square and greater than the previous calculated value, that will become our output. With this example, I hope you are able to identify the pattern. All we need to do is identify the rows and columns which are removable but consecutive to each other or next to each other. Only then we can build a bigger square. In this example, because the vertical rows were at position 2 and 3 which are next to each other, and same applies on the horizontal rows as the two rows were 2 and 3 next to each other or consecutive, we were able to build a bigger square. If they were not consecutive to each other, then we would not be able to build the streak or the longer side, giving us a better results. At a high level, in our implementation, we'll start by iterating through all of the vertical and the horizontal bars to identify how many items are consecutive. Once we know the maximum streaks of consecutive numbers for both horizontal and vertical, we'll compare it with each other. Comparison is needed because we are trying to build a square. So the smaller number between the two rows and columns will become the side of the square. The time complexity of this solution is going to be O of h log h plus v log v, because we need to first sort the input arrays for vertical and the horizontal bars to identify how many consecutive numbers are there. While the space complexity will be O of 1, that is constant space, as we'll be doing in place sorting. I hope this was helpful. Let's walk through its C# implementation. In this C# implementation, I'll be using a helper method called longest consecutive, which accepts integer array as an input. Starting with a basic validation to return 0 if the input array is null or length is 0. The next step is to sort the input array into ascending order and then start a for loop to iterate through all of the elements, starting with the first element all the way till the end. Within the for loop, we'll compare the current value that I is pointing with the previous value to see if they are consecutive. That is, the difference is only 1. If yes, then the current streak counter will be incremented and we'll check if the current streak is greater than the maximum streak. If yes, then we'll save the current streak value into the maximum streak. In the else condition, I am resetting the current streak to 1 so that we can try again. This code also handles an edge case where we have duplicate entries in the input array. For those scenarios, we don't want to reset the current streak, instead let it continue. From the main method, I am calling this helper method multiple times, one for horizontal bar and then for the vertical bar, Then I'm calculating the smaller value between the two using the math.min operation. Once I have this side, I am multiplying it with itself to get me the area of the square and returning it as the output. This code when submitted on LeetCode meets 18% of the submissions in terms of runtime and 100% in terms of memory. Thank you for watching this video. I hope this was helpful. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.